Hi, everybody. My name is Clay. Thanks very much for joining this talk on observability and how that connects to PagerDuty incident response workflows. I'm a partner engineer at Lightstep, and I'm excited to be here to talk to you about that today and show what that looks like with a brief demo. So yeah, we'll go ahead and get started and kick things off. All right, so before we dive into it, I wanted to give a quick overview of just what we'll be talking about in this lightning talk. So because we do get the question a lot, wanted to just share a little bit about Lightstep's perspective on what is observability and what that means in the context of PagerDuty incident response. And then from there, we actually want to show what it means when we take something like a PagerDuty incident and connect that to observability data. And when we make that connection, we can actually build some pretty interesting workflows that we think are really helpful for development and SRE teams, and we'll actually kind of show what that looks like. So that'll be the demo portion. And then lastly, we'll wrap up with some links and some next steps if you're curious about it. We know a lot of the things we're introducing today are relatively new or experimental, but we really just want to start the conversation with people and show what's possible, particularly as more and more organizations adopt OpenTelemetry. So with that in mind, let's just dive right in. My name's Clay. I've been in the observability space or in the incident response space for a while. I'm really passionate about this and, love to talk about ways that make something like responding to an incident, getting a page in the middle of the night, easier and faster for teams. And so hopefully that's what you will be showing today. We get the question a lot around, so like, what's the difference between monitoring and observability? And I think a lot of that is partly pushback around observability being perceived as maybe a term that's been exposed a lot in the past couple of years. And there's different ways to define it. There's some really wonderful articles from people at Lightstep, but for purposes of this talk, I want to kind of situate it in a incident response workflow. So, whether you're using something that would be called a monitoring tool or something like Lightstep, whether we call it an observability tool, for something like incident response, it starts with a PagerDuty alert. And, you want to get to the end, you want to get to the solution and fix things, the same end result for both sorts of workflows. But with observability, there's this idea of using that data to very quickly validate a hypothesis, pulling in all the relevant data and getting to root cause really quickly through some automated fashion or an improved workflow or an improved UX. So difference being monitoring, maybe spending, several hours digging through logs, SSHing into servers, trying to figure out what's going on, versus kind of having some hypothesis based on your telemetry, kind of having that surfaced for you and being able to make a decision and choice really quickly. And that's all we mean by observability versus monitoring. So we know that there's a number of different solutions in this space. The thing to keep in mind and the advice we give people is, any solution that calls itself an observability solution, should help you very quickly go to root cause from some sort of change to your system, like a deploy or a configuration change or some infrastructure change. And that's what we mean when we say that. So Lightstep's perspective on kind of answering that question around, well, what change is a feature we call change intelligence, and we'll be showing this shortly. But the idea here is that from all of this data we're collecting from running applications and infrastructure, we can use correlations within that to kind of get to the impact of how that change is affecting services and ultimately the customers and people that are using those services. Within that is a lot of different types of workflows. Obviously, observability is not an island. You're using Slack, you're using PagerDuty, you're using a lot of different sorts of solutions to kind of respond to something that's going on in the system. And a big part of that is metrics and traces, so the actual telemetry types themselves. And so if you're really lucky right now, if you're using an observability tool or a monitoring tool, there's this divide between the charts and graphs you're looking at and different tools and systems that are more event-based. So a really good example is a deploy from say, a CI/CD pipeline. So you make a code change, and if you're lucky and if you configured it, most tools support some sort of overlay where you see a line on a chart, and you can get to this idea, well, I did this, and then the chart did this, that must be the reason behind it. The issue is, while that's extremely effective for some teams and for some types of our software architectures, when you're talking about a really big system that might have dozens or hundreds of services, and each of those services is owned by a different team, and that team is constantly making new configuration changes, deploys, all of those things, this just scales really, really poorly. And so what we wanted to do, or kind of what we wanted to explore, is how to kind of bring this idea of connecting an event like a PagerDuty incident into telemetry in a similar way that we already do with deploys. And specifically how we can use that to help better understand these complex architectures where an entire system might have a lot of different incidents going on at a single time. So we built this experimental OpenTelemetry integration. OpenTelemetry is an open standard that lives in the CNCF. It's also where Kubernetes lives. And it's really just an open API and a standard that lets you effectively hook into metrics, traces, or logs that your code or someone else's code emits. And because it's an open standard and because you can do what you like with it, we created an integration where we're actually using PagerDuty incident data, specifically a webhook from PagerDuty, to automatically tag telemetry from a service. That's kind of a long-winded way to say that when there's an incident, we're going to tag all of the measurements we are collecting about that service with that incident ID. And because we've made that explicit connection between the data we're collecting about running code and PagerDuty incidents, we're able to build some new workflows that are pretty interesting. And we're building that all in open standards, so it's not specifically tied to Lightstep. It can be used by any OpenTelemetry aware solution. And that's exactly what we want to kind of show today. So with that in mind, we'll jump right into the demo. So, as is typical in demo applications, it's not a real environment. It is built in a cloud native sort of way. This is a Kubernetes. This is an app running in a Kubernetes cluster in Amazon Web Services. It's vaguely inspired from an e-commerce application. We have a way to order donuts. It's instrumented, so we're generating metrics and traces when someone orders donuts. Here we're ordering a lot of donuts every 3 seconds. So from there, just a little bit about the architecture itself, because this is going to be really important once we start making the connection to an active PagerDuty incident, is that we've got, in this case, around 4 to 5 services, depending on if you count the web browser service. But long story short, we have a tea service, a donut service, and a coffee service. And all of those are behind an Nginx ingress controller, which is a popular way to proxy requests into a Kubernetes cluster. So what's happened, though, and kind of the situation is that through an alert in Lightstep, we have created a PagerDuty incident because latency, something unknown has happened with this Nginx service here in blue. And we can jump over to PagerDuty and we see that we see the message that the latency is elevated and it's assigned to me. And unfortunately, I'm the only one on call in this demo environment. So we go from here to PagerDuty, there's an incident. And of course, as we described in that previous workflow, if you're a responder in this context, you want to really quickly understand what happened. Like, why is latency elevated? Is it related to some change I made? Is it not my problem? Is it someone else's problem? Is it caused by some other service? In this case, if latency is increased in Nginx, is it the fault of the coffee service, the tea service, or the donut service? And so not to completely bury the lead, but the change intelligence hook and the connection to Lightstep, the product, is really just a single or 2 clicks, I guess, effectively. So we want to investigate why this chart in purple spiked effectively. These are metrics related to the Nginx that we're collecting. We click on it and we choose what caused this change. And from there, we're running a bunch of different analysis on the metrics and traces of that Nginx service and also how that connects to all of the upstream services. So we see the biggest recent changes, and here's the interesting thing. It traces with PagerDuty incident number 18. So because we made that connection from PagerDuty to the telemetry we're collecting about that service, we've noticed that things got kind of interesting when that active incident number 18 was present. And we can do a before and after comparison, see things like latency, error rates, and then drive into other services too. But that's really like kind of the 2-click observability workflow of using all of that telemetry data with the right tags to kind of quickly get to this, to quickly validate a hypothesis and understand what's behind it and what are the related tools and systems that are involved. In this case, we know there's an active PagerDuty incident. So that's the short version. Wanted to spend a little bit of time going into how we're able to do that, because I think understanding how is really important. It also kind of describes where the OpenTelemetry standard fits into. So, so in this case, let me back up here. In this case, we've got a number of different traces we're collecting. Let me just go back here. And we have the ability to kind of query all of that telemetry. So this is just a way you can use Lightstep to kind of understand or query all of the traces that are coming into the system. In this case, because we're collecting the PagerDuty incident data in the telemetry, we can write a query that says, show me all the traces that have an active PagerDuty incident. It goes out, fetches all that telemetry, aggregates it, and then we're also going to group it by the active incident ID as well. So at any given point in time, you can then query the system to say, across all my services, tell me what the active PagerDuty incidents are. And if you click on the active incident, then you see all the associated distributed traces with that incident ID. So if we click on one here, I've already loaded one up. You can then see the trace. This is the waterfall view of how the request flows through all of these different services and systems. But up here on the right-hand side, if you scroll down, you'll see pagerduty.com active incident, and that's the actual incident ID of the incident that's open when this data was collected. So we've added a workflow link that means, which means that because it knows that attribute exists, it makes it really easy to jump back into PagerDuty from the telemetry. So in this case, we know that because this is a problem related to the Nginx ingress controller. It triggered incident number 19. And if we click that, we jump back into PagerDuty. We see the incident's been resolved, and we can see the timeline and details related to that. So it's a really interesting way to go from an alert that goes from Lightstep to PagerDuty or any monitoring tool to PagerDuty. But because we've added that PagerDuty data back into the telemetry we're collecting from the system, you can then go from the monitoring tool, in this case, Lightstep, back into the PagerDuty UI. The last piece of this, and I think one thing that's more useful for kind of historical analysis, is because we know when an incident happened in PagerDuty, we know what service it was associated with. We can go back pretty far, in this case, 24 hours or up to a month, to kind of look at the historical timeline of latency, error rate, and traces whenever there was an incident for that service. So typically for a lot of monitoring charts, this would not be what you want to see, all of these gaps. But in this case, this is exactly what you want to see, because it means that in these gaps, it means there was no active PagerDuty incident associated with that service. But it also kind of enables you to answer these really interesting questions and do analysis around, well, what was my error rates during this incident, or what was my latency during this incident? And then if you click into the trace view, you can then understand how that impacted all of the upstream or downstream services. So this is kind of a more advanced use case that gets really into the nitty-gritty of the telemetry and kind of doing historical analysis. But it's all based on this data that we're collecting from OpenTelemetry that makes it significantly easier to make that explicit connection between a PagerDuty incident that happens and eventually ends, and how that relates to all the telemetry you're collecting from all of these services in potentially a very complex environment. So we think this is really an experimental case, but it's the beginning of, we think, of a lot of different interesting possibilities. We've started to kind of document and share different sorts of things in the broader DevOps space around what you can do with this. We think incident response is a really key one, but we're also sharing different sorts of examples with feature flag vendors like Split.io and LaunchDarkly, It also applies to deploys and GitHub Actions and CI/CD workflows. But because OpenTelemetry itself is an open standard, we've made almost all of these examples and use cases open source. You can check out the Lightstep Partner Toolkit if you want to dive into code. If you're just getting started with OpenTelemetry, we've also got a really nice introduction, kind of how to get started, what the migration path to OpenTelemetry looks like, available at opentelemetry.lightstep.com. More resources are always being added, and we're generally really excited as more and more organizations and vendors adopt this technology around the different workflows we can build, and ultimately, hopefully make it really easier, make it much easier and faster to get to root cause and close out incidents quickly. So that's it for the demo. Thank you for attending the talk. We'll be online to answer questions, and you can always reach out to us at lightstep.com/partners. Really appreciate it. Thank you.